So I'm recording the session just to let everybody know. Welcome again. I hope everybody's safe at their home or offices, whatever they are in the world. Thank you for attending. This is actually a webinar series of webinars that ACCESS.SPACE is actually organizing to support you while you're at home, as well as the industry and the sector who may be struggling in let the words out and also let them grow in their business, basically. We will be recording the webinar so that other people can watch it after us. We will allow people to speak and actually ask questions at the end of each presentation, and then we'll have also a short 5 to 10 minutes Q&A session at the very end for all the panelists together. So everyone is muted, as I just said, and you'll be given access to speak when you ask questions. Otherwise, you may also raise your hand. There's a little hand at the bottom of your screen. If you click on that, I will know that you want to say something, and I will let you in at the end of each presentation. If you want to join the ACCESS.SPACE Alliance, I'll give you a little bit more details now, but you can also go on our website, ACCESS.SPACE. We'll give you additional information. In terms of the webinars, this is the 5th webinar. We have some great webinars so far. We'll show you what they were over the last 4 weeks and also what will be in the future. Each week, I'm seeing an increase of interest in our webinars. This week we had 136 registrations. Usually about 70% of those registrations attend on the live webinar. In fact, when I analyzed the countries of interest of these webinars, we have basically 31 different countries, of course, because the industry is quite fertile in the UK. The small satellite sector is fertile with many companies in the UK. We have a lot of interest of companies to attend from the UK. It's not because we're based in the UK. It's because of the fact that it happens that they know me and I know them, and they've been invited. But if you know of anybody else in your country that would like to join in these webinars, please expand the network, and I can invite them at the next webinars in the future. So Italy, Switzerland, France, India, USA, some of the participants keep on coming back with a lot of numbers of companies as well, and many single countries from other places of the world, Europe, but as well as even the Middle East and Asia as well, joining us. In terms of companies, at this time I've done a breakthrough of the interested attendees at this webinar. A lot of engineering consulting companies, business, IT, finance, spectrum, licensing, and so on are attending this webinar. About 28 or 30 companies have an interest to this. Plus, you see that there's a lot of engineering firms, manufacturers of satellites and equipment as well as government agencies, IGOs, a lot of the telecom regulators that I know myself. In fact, a few space agencies and universities also attending this live webinar. I suppose a lot of people would like to continue their interest and understand where the sector actually is moving. Just to remind everyone that we represent these sort of small companies. However, we also have large companies interested in ACCESS.SPACE, but the majority is in fact small companies. The past webinars, you see this on the left side, week 1, 2, 3, and 4. Here are the companies that have so far spoken. Anybody interested to receive their presentations, let me know. Just send me an email. You have it already. Future webinars starting from next week, week's number 6. There'll be a Spectrum webinar happening next week. But then we'll go back to sort of a mixed presentation from several companies that you can see, either engineering or either finance or insurance companies presenting. There are places open for the future, starting from the 10th of June. If anybody is interested to do a presentation of their company or their project, you're all most welcome to let me know, and we'll accommodate you to make a presentation. ACCESS.SPACE Alliance is formed by these 3 directors and co-founders, Betty, myself, and Christian from Germany. Their emails, so you can see, are on the screen. We formed the company last year. We are a non-for-profit industry association or such, or sector association. Let's not just call it industry, but sector at large. We don't just represent the companies, but also institutions as well. Our mission is to basically boost the small seller sector, and then creating an environment which is in support basically of these companies. So far, we have had an interest of about 76 companies and organizations to be part of our association. We have offices in the UK, France, and Germany. So again, if you're interested to join us, let us know. So far, the interest is on this slide. A lot of companies that you may or may not know have asked interest into joining us. That's basically where we are at the moment. The breakup of companies, you could see there's a lot from the UK, European, American, as well as the rest of the world. That's the way in terms of distribution around the world for the interest. Let me just say one last thing before we start the webinar. If you are hiring people, if you're sponsoring students or new graduates, let us know. We can help you fill in that vacancy. We are trying to help people that may be in difficulties this time. I know a few people from Webb, for example, and a few students that are looking for opportunities. So mistake here, it's webinar number 5. Panelists, great panelists today with Deimos, Endurosat, and also CST. They're going to present themselves. Here are their emails. I understand from several people they would prefer looking at some of their emails in case they need to contact them directly. Here they are. They will have emails and contact details also as well from their presentation. So we're going to start right away with Phil Davies with Deimos, then Giuseppe, and then afterwards Alan. So I finish with my presentation. I'm going to stop sharing my screen. If you have any questions, I'll take them up at the very end on ACCESS.SPACE. Philip, is all yours. If you can share your screen and your presentation, and then I'll keep quiet.
Okay, thank you, Tony. Is the screen visible to everybody?
It is, yes.
Okay.
Let me just say one thing. At the bottom of the screen, people, you have your Q&A window. During the presentation, just write any questions you might have on that window, and then we will ask them at the end of the presentation. Thank you so much.
Okay, thanks, Tony. So just before I start the talk about Deimos, I'll just give a little bit of background about myself. I think I know quite a number of you who are connected, but there's also quite a number I don't know. So I'm Philip Davies. I've been working in the space industry now for 38 years. Started in 1982, working at a company called ACCESS.SPACE, located in Toulouse, now part of Airbus. At that time, I was working for Logica, which is now called CGI, and I did a variety of projects for them for 24 years. Also co-located at ESTEC and ESOC for about 7 years. After that, I spent 11 years as the Business Development Director for SSTL, looking after Europe and North America. And then in 2014, I joined Deimos when they set up a UK subsidiary. I ran the UK subsidiary as the CEO for the first 5 years. I now work not full-time, so I'm now their Business Development Director. And the CEO of the Deimos Group, Ismail Lopez, who's based in the UK, is also the CEO of Deimos UK now. Okay, so a little bit about the company. So Deimos is part of a group called Elecnor. So Elecnor is a large company, global company, headquartered in Spain. As you can see, it's quite big, 13,000 employees around the world, about half in Spain, half in the rest of the world, and a turnover of about 2.3 billion euro. So they are mainly focused on large projects, principally in things like the electrical industry and infrastructure projects, for example, in railways and so on. So they're a very, very big company, and they 100% own Deimos. Deimos is basically the high-tech part of the Elecnor group. So Deimos is around 400 engineers. About 2/3 of Deimos is focused on space. but we also have other divisions looking at sectors like aeronautics, maritime transport, general IT, and so on. Deimos was founded in 2001. It's been around for about 18.5 years now, located in 5 countries. So if you look where we're located, so headquarters are in Spain, Tres Cantos, Madrid. And we have other facilities in Spain. We have a space center in the south of Spain, close to Ciudad Real. We have subsidiaries around Europe in Portugal, UK, Italy, and Romania. And as it mentions on the top left of the slide, we are a shareholder in Orbex, who are located also in the UK, Denmark, and Germany. So that's where we're located. So what do we do? For a relatively small company, we're actually quite unusual because we're completely vertically integrated. We operate in both the upstream part of space, so typically working on space projects, all the way from launches through to satellites, but we're also very active in the downstream part of space, where we work on applications that use space data, typically Earth observation and navigation data. They're the 2 biggest application areas. So we generally work across the whole life cycle of a project. We tend to get involved very early in a lot of space projects. We are one of the leading companies in Europe for doing mission analysis, and mission analysis is one of the key activities at the start of a project in phase 0 and phase A. So you typically find us in most of the ESA programs in the phase 0 and phase A's, and in some of those we end up working right the way through the program. We also do our own missions, and I'll get onto some slides about that a little later. So the key areas of space that we operate in are space science and exploration, sat-nav, Earth observation, space situational awareness, and launch. So who are our customers? They're mainly in Europe, although we do have some contracts outside of Europe, and they're broadly split between institutional customers, people like space agencies, European Commission, and big institutional space customers like EUMETSAT. And then on the commercial side, we do work often ourselves, but also through pretty much all of the European prime contractors. So we work with Airbus, Thales, OHB, SSTL, and so on. So briefly go through each of the domains that we operate in, give you a few highlights about what we do. So in the science and exploration field, we do a lot of work on flight systems. So that's mainly around engineering support and software, and particularly focused on things like GNC, guidance, navigation, and control for both satellites and launch vehicles, and AOCS for satellites. Also upstream, we do a lot of work on ground segments, so particularly satellite control, but also the rest of a satellite ground segment, monitoring, controlling the network, doing the mission planning, the scheduling, the automation, and so on. So SatNav, we're mainly focused on, in the upstream part of SatNav, mainly focused on the 2 big European programs, Galileo and EGNOS, but also we have now started work on the UK GNSS system. So we're also involved in that now. In the downstream part of satellite navigation, we're active mainly in 2 distinct areas. One is receivers, where in Portugal we have developed our own GNSS receiver based on FPGA technology, but also we do a lot of applications work where we make use of GNSS data. We have our own system for doing location-based services, for example. EO is a really big area for Deimos, probably the single biggest area, and we are active right across the whole of the EO area. So we're involved in a lot of ESA missions, but we also do our own missions. I mentioned the vertical integration before, so for some missions we are actually the mission prime. We build the satellites, we build the ground systems, we operate them, and we provide user services. Let me just focus down on a couple of things. On the ground segment side, we have our own product called GS3O. That's the complete ground segment for an EO mission. We use that to operate our own satellites, but we also make that available as a product for sale on the market, either as a complete system or in terms of modules. Some of the other things on that slide I'll get into on some of the future view graphs. So we have our own space center. So this is the Deimos Space Center located in Portellano, about 60 kilometers or so south of Ciudad Real in Castilla-La Mancha area of Spain. So at that facility, we have offices, we have clean rooms where we can do satellite integration. Our approach to satellites generally is that we don't build hardware. We act as a mission prime, we procure hardware, but we do a lot of the software systems, which are the glue that connects everything together. So we have our own clean rooms in that facility. We have our main satellite control center there, and we have a ground station built around a 10.5 meter S-X-band system that we have there. So in terms of the satellite missions, we have a satellite systems division. So they look after this side of the business. So they will do the integration and test of satellites that we build. They're responsible for the launch. Through that satellite control facility, we can do the operations of the satellites. Oh, sorry, it's going the wrong way. So just a brief zoom in on the first couple of missions we did. So back in 2009, we launched Deimos 1. That was our very first mission. On this mission, we didn't build the satellite. The satellite was part of the disaster monitoring constellation of SSTL, but we built some of the software systems around that we used in the ground segment, and we commercialized the data. So that was originally a 5-year mission. The satellite still operates. I'll get onto the satellite ownership in a minute, but both Deimos 1 and Deimos 2, which I'm about to talk about, were both financed by Deimos itself. A few years ago, I think 3-4 years ago, we sold both of those satellites to the Canadian company Earthcast. So although we're still involved in the operation of the satellites, we're no longer the owner of those missions. And Deimos 1 was very successful. Originally specified for a 5-year mission, 10 years on, it's still working and producing valuable commercial data. Deimos 1 was a wide area imaging system, so it takes very wide swath images, 600 kilometers wide, at a resolution of 22 meters, and it really is quite a unique system. Single biggest customer for Deimos 1 is actually the US Department of Agriculture, because although the US has a huge number of its own satellites, it can't get regular coverage of the whole of the continental US, which they need for agriculture. So Deimos 1, together with the UK DMC2, provide a fortnightly complete coverage of the whole of the continental US. It's a fairly unique data set at that resolution. Deimos 2, which we launched in 2014, was quite a different system, much narrower swath, 12 kilometers, much higher resolution. So the data products that we sell, the pan-sharpened product, 75 centimeter pixels. So very, very different satellite, very different market. The business model here was also slightly different because the satellite was actually integrated in Spain, went through the system testing at Deimos's facilities, went through the environmental testing at Spanish government facilities, and then went straight from Spain to the launch site, and then was operated by Deimos from the launch. As I say, that mission is now owned by Earthcast. So we did these 2 missions, and in future we're continuing this line of business. Let me just take a drink of water. We're continuing this line of business. Next generation satellite, which is called SAT-3O, which we're currently building partly through a Deimos internal initiative and partly financed by European Space Agency through the InCube program. What this is doing is it's taking a much better capability than we had in Deimos 2, reducing the mass of the satellite, reducing the cost, and producing even better quality data. So we're targeting with this satellite 50 centimeter pan-sharpened data products, trying to get the mass down below 200 kilos so that we can make use of the new generation of launch vehicles like Orbex, and offering a better price performance ratio to the customers. This is designed not only to be a single satellite, but it's also designed to operate in constellation. So with the agility of the satellite and with 3 of these satellites in the same orbital plane, you can do daily imaging of anywhere in the world, as shown on the image on the slide. Okay, this is just a little look at our ground system. So we call it GS3O. It is the complete ground system for an EO mission, and it's everything that you need to do the upstream part, plus it also contains applications and user services. So we use this on Deimos too. It's flight proven quite well now, and some of the modules we've also sold to third parties. For example, some of them are used by institutional customers in Europe. You can see a list there actually on the slide of some of the missions that use some of the modules. So as well as doing the upstream, we do a lot of the downstream activity, and this is actually the single biggest thing we do in Deimos UK. So about half of Deimos UK, which is about 30 people at the moment, half of Deimos UK is working on EO applications. We've been doing this right from the start since 2014. It's grown quite well. We've changed how we do this as the years have gone by. We originally started by doing typical EO applications using algorithms developed by clever people. Now we generally don't do that. We generally use machine learning. So we use AI for the applications. So most of the work we do now involves training neural networks, and then using neural networks to do the information extraction from the images. And that's worked really, really well. And we get very good results, just as good as we get from specifying very complex algorithms.
Philip, just 1 more minute if you can. Thank you.
Okay, I'll briefly. I think I'm quite far through. I'll just briefly cover SSA and launch. So Deimos very active in all aspects of SSA. So the 3 key areas: space weather, space surveillance and tracking in near Earth objects. And in the UK, we mainly focus down on the space weather and the space surveillance and tracking. So Deimos has its own system for space surveillance and tracking. We have our own observatory in Spain, and we have the complete software system that sits behind all of that. So we can take measurements, process measurements, plan measurements, process the data, correlate with catalogs, and then do all of the services that you can see there. We can do collision risks, re-entry analysis, and so on. So very, very active in space situational awareness, space surveillance and tracking. Finally, I'll just talk about launch. A couple of references here. We did a lot of work on the IXV, the ESA intermediate experimental vehicle. So we were responsible for the GNC. And most recently, we invested in the Orbex initiative, and we're working very closely with Orbex. We've been involved in the UK launch program now for about 4 years. We ran the original studies that looked at doing launch from the north of Scotland, the so-called SEPTA project. We supported Orbex in their bid for a grant, and we're currently working with Orbex on the development of the Sutherland Spaceport. We ran the study for the UK Space Agency, looking at how you do the range for the Sutherland Spaceport, and we've done several other studies. But the key thing we're doing from Orbex, outside of the grant work for the spaceport, is the development of the GNC for that vehicle. So very, very happy to be involved in that very exciting program. Okay, I think that was about it, Tony. That's the end.
Right, thank you so much. Can you unshare the screen if you don't mind, Philip? And then we can ask questions. Do you have a slide with your contact details?
Well, it was on slide 1.
Can you put it back on and share the screen while we ask questions? But if you can, if you don't mind, so that way, as you answer the question, people can write down your contact details. Also, let me see. I have Pierpaolo Gigino asking for the floor. Let me get Pierpaolo to speak. Pierpaolo, you are. Let me see. Pierpaolo, can you try your microphone and speak? Let's see if it works. Okay. Yeah, go ahead, Pierpaolo. You can speak now.
Yeah, yeah. It's just a kind of a curiosity, really. I mean, we are talking about mostly is visual, is visual sort of observation. You're not really dealing with telecom telecommunication with the devices and also with the network management that you are running the satellite on.
Yeah, you're right. We're not very active in the telecom part of space, but that's not to say we're completely inactive. We are involved in some initiatives, particularly ones that use constellations of small satellites in low Earth orbit. I think we're not involved in big geostationary missions, but we are involved in several initiatives looking at doing low cost comms from the low Earth orbit. But it's not a major line of activity. We don't have it as one of our 5 key lines of activity, but it is something we are interested in growing in the future.
I have another question from Mohammed Ali Gabe from Tunisia. I'll read out the question on the screen. What are the uses of a single small satellite? Because Tunisia is planning to launch its first nano satellite soon from Russia.
Yeah, and it depends what to answer the question, it depends what the satellite is. I mean, the satellites we've been doing are Earth observation satellites, and the previous question was around what these missions were. They're actually imaging the Earth in visible and near infrared. So near infrared is actually quite useful for agriculture. And the visible is, for a lot of other applications. So I'm guessing your Tunisian satellite is for Earth observation. With one satellite, if you put it into something like a sun-synchronous orbit, you will be able to image anywhere in the world. Depending on the agility of the satellite, you will have to wait a certain number of days. If it's very agile, you will get with one satellite, you can get an image within about 3 days. If it's less agile, it might take more like 1 or 2 weeks. But eventually, anywhere in the world will come under the orbit plane of the single satellite, and you can image anywhere in the world with it.
Okay, I'm going to save the next question from Robin Tucker to later when we have the general Q&A. I'd like to get now Giuseppe Sisinni, Endurosat on. Philip, can you unshare your screen, and I can get then Giuseppe to share his screen and start his presentation, please. And then we'll get more questions for you at the very end. Thank you.
Just a second. Okay, can you see the screen?
It's on. Thank you.
Full screen, maybe it's easier.
That's it. It works now. Thank you.
Okay. Hello, everyone. I hope you can hear me well and you can see the screen. Tony, thank you for organizing these webinars, which we found very interesting so far, and to get known what our friends in the other space industries are doing it. So thank you again to ACCESS.SPACE in general to organize these webinars. A little bit about myself. My name is Giuseppe Sisinni, and I'm a space engineer from Sapienza University. I have a technical background, but currently I'm working as a head of sales at Endurosat. I have joined the company day one, so I really share the spirit and the vision of the company. And in this presentation, I'm gonna talk a little bit on what we do at Endurosat. The mission of Endurosat is to really redefine the space industry by simplifying satellite technology and operation. And we are doing it developing satellite technology, which is, as we said, as simple to use as a smartphone in space. So it might sound as a tautology for the sector, but we don't want to see the satellite as a rocket science, but we want to see the satellite to be seen as a commodity space. Endurosat was founded at the beginning of 2015 by a team of 5 engineers in a small apartment in Sofia, with the idea to design satellite systems from scratch. Currently, the team is 48 people. Of course, most of them are still engineers, covering all the expertise on the field of satellite technology. And still our headquarters and labs are in the center of Sofia. So Endurosat operates in the markets of nano and microsatellites, so satellites a little bit smaller of the previous ones, so ranging from 1 to 100 kilos. And as I said at the beginning, we started with the idea to design modules from scratch. We didn't want to be integrator, but we wanted our platforms to be based on a full Endurosat technology. And after 3 years of hard work, we managed to fly our first mission in 2018, which was deployed from the International Space Station. It was a big achievement for us because in 3 years we managed to put satellite in orbit, and this one was also actually the first Bulgarian satellite which was designed and developed in the country. Currently, our portfolio of products of satellite subsystem is much larger. You can name them. We have solar panels, body-mounted and deployables. We have radio systems. We have power systems. And the latest generation of these products, even though are still compatible with the CubeSat design specifications because they can be easily integrated in a 3 or a 6 unit platform, due to their high performances and capabilities, they are actually used mostly in larger satellites, I would say the size of 100 kilos. Of course, all of our system underwent a full campaign of tests at qualification level, which follows the usual standard in space, so NASA, GVS, and ECSS. And most of our system have flight heritage in multiple missions. We do have more than 150 systems already in space. So on the basis of the subsystem technology, of course, Endurosat can provide full platforms ranging from 1 to 12 unit size. In the last 2 years, we have invested also on the ground segment. We own an antenna which is based next to Sofia. I'm going to talk about this ground segment services a little bit later. But what I want to say here is that Endurosat at this point can manage the entire complexity of a space mission. So from the mission analysis, of course, providing satellite technology, we can integrate the payload of the customers. We can offer launch assistance through our partners in the launch industry. So negotiating the contract, negotiating the terms of the integration of the satellite in the rocket. And through the ground station, we can offer operations after the deployment in space. Over the past years, we have developed a very unique satellite store, which you can see on our website. And from the beginning, we wanted to be very transparent with our customer and sharing as much as information as possible on our system. So you can download datasheet, you can request us step file, so you can check mechanical compatibility with your system. And it was quite unusual only a few years ago, but we were sharing real prices of the systems without ambiguity, not starting from, but the real price. And believe it or not, we had even customers that they ordered systems directly from the website without even contacting us. Another feature of the satellite store is that it includes also a satellite configurator. So basically, you can start playing with the systems, and you can have a first preliminary idea of what will be the performances of your satellite. For example, changing the communication module, you can see how you change the data rate of your satellite, or you can change in the power systems and solar panels. You can see how much power is available to your payloads. We still define ourselves as an R&D company, so we have capabilities of design and build new systems, of course, we can fully customize our existing modules. We manage also to close the loop of the production entirely in the region, which give us full control of the production itself. And of course, this has a few advantages. For example, we can easily scale up to mass production, and it's very useful when we work with commercial customers like constellation programs. And also, we can guarantee a very fast delivery time. I think that we have probably the fastest delivery time for satellite systems, since we can dispatch satellite systems in less than 5 days. Basically, we receive the order, we have stock of the system, we test them, and we clean and pack in a clean room, and we can dispatch immediately after the order. As I was mentioning at the beginning, we own a ground station which is based right next to Sofia in a tier 3 teleport. No need to say that this ground station is fully compatible with our communication system in UHF, S, and X band. And of course, we are flexible to reconfigure based on customer needs. I don't know, for example, integrating new modems. The antennas are in UHF, commercial and amateur frequencies, in S and X band commercial frequencies, protocols are DDBS, CCSDS, but as I say, we are very flexible to reconfigure it based on the customer requirements. There is a nice approach with the ground station, which basically the client has web-based access through an API and a dedicated web application. So the first thing to do is you find a very easy scheduler component to request the connection. Then there is a configurator which allows for settings like frequencies, modulation, polarization. No need to say that it has an automatic tracking of the satellite. So when your pass is booked, the antenna directly tracks your satellite and downlink the payload data on the configuration that was set before. And since it is based on the Amazon AWS services, it's basically cloud driven. The shared satellite service. From the beginning of next year, we will launch this new service, which is basically a hosted payload service, which is designed to give our clients a very easy access to orbit. So they can perform experiments, they can test new technologies, they can achieve flight heritage. So basically to do IOD or IOV missions. Basically, this is the easiest way to get to space, because the client does not need to operate or to own the satellite or the ground infrastructure. The client would simply give us the payload, which we will integrate on this platform, and they can have direct access to the payload data, which will be available on the cloud that I was talking before. The first configuration of this satellite will be a 6-unit CubeSat, which is capable of operating 12 payloads, and each payload has access to onboard processing, power, and pointing capabilities. The first mission, as I said, is at the beginning of next year with a satellite which is called Spartan, and it will be launched in February 2021 with a Falcon 9, and these services will be then on a quarterly basis. So we will launch one of these satellites every quarter. For the first mission, actually, we still have spare capacity. So if someone has a ready payload to fly, please, you can contact me, and we'll see if we can integrate your payload in our platform. Probably you have understood that at Endurosat, we really think that the access to space now is cost inefficient, is is complex because each user has to manage and pay the entire value chain of the space mission, which means that this will lead to high cost and also limitation in mission capabilities. For example, the current nano satellite flying in the orbits, they lack the capability of on-demand data stream or on-demand command and control. So we will working on launching this service, which enable a groundbreaking new model of using nanosatellites, really transforming the satellite industry into a space data service. So with this project, we will create a decentralized space data network connecting nanosatellites on demand and transferring valuable pale data through the digital ground station mission control, which is actually up and running currently, as I said before, and then directly to the cloud-based user profile. So the final user will have access to a very user-friendly interfaces, and he can focus and work on what he does best without checking and managing the complexity of the full space mission. Just to summarize what I have briefly said about Endurosat, I'm glad to say actually that we have more than 85 customers at global level. We enable commercial customers, we enable universities, research organizations, even space agencies to solve their challenges. Our systems have full flight heritage. We have more than, as I said before, more than 150 subsystems in orbit and 5 full platforms based on Endurosat technology already in orbit. We own a ground station which works in UHF and X-band, which is fully integrated with the AWS services and features this unique digital mission control. We do have complete in-house capabilities to design and customize nanosat technology. And the additional point that I want to stress is that we really have the fastest delivery time on the market. And this, in the previous years, it really helped few of our customers not to lose the flights because we guarantee them a very quick delivery time. So thank you for having me, and I'm open to any questions. Hello, I cannot hear anyone. I don't know if.
Sorry, I was in mute. I didn't realize I have two microphones, 2 buttons to deal with. Thank you so much, Giuseppe. Very interesting presentation of your company. Very unique, especially based in Bulgaria as well, in Eastern Europe. Very innovative and forward-looking. I have an anonymous question, which says, is there any limitation to send our payload in your shared satellite? Again, it doesn't specify what kind of payload that is, but that's the question.
Well, definitely there are limitations. As I mentioned, especially the first configuration of these satellites will be 6 units, and 3 units of these satellites will be full by Endurosat avionics. So one limitation can be the volume itself, which is 3 units. In terms of power, pointing capabilities, we can customize the satellite platform since we have our own technology as we prefer. So we can, add more power using more deployable solar panels, or using, different communication systems. We can achieve higher data rates. So definitely there are limitations, but these are easily understandable. I mean, we require very high level of requirements of the payload, and then we check if it is feasible or not to fly the payload in space.
One last question, and then we'll take the rest at the end. What are the well, have you done anything to mitigate radiation damage, especially single events effects on your system? That comes from Richard Sharp.
Our systems, of course, are fully redundant. We have even tested, we have performed some radiation tests at CERN in Switzerland, actually. Definitely, they are nanosatellite systems, so they are based on components which are not hard rad, otherwise they wouldn't be nanosatellites. And as well, our software has several redundancy level, which guarantees us at least 3 years lifetime in LEO orbit.
All right, I'll have 4 more questions. Please don't delete them. I'll ask them at the end in the Q&A session, general Q&A session for Giuseppe. Can I get now Alan on the screen? If you can share your screen, Alan, with your presentation, and I will save the questions I have received for the end. Thank you so much. Got it, Alan?
Hi there. Can you see my screen?
Yes, we can. I can at least. Yes.
Okay. Better. I'll start with my video. Can people see me as well?
That's fine. Go ahead.
Oh, okay. So thanks for the opportunity to present, Tony, and thank you to everyone at the ACCESS.SPACE Alliance. This is also apologies in advance for the background noise from my computer. I'm hoping it will calm down in a little bit. Just to give an introduction really to commercial space technologies, the company I've been working in for the last 10 years. Right, to start off and go back to the beginning, we've been established for over 35 years. Started off as a consultancy catering to the insurance industry, and since then the company has grown this side of the business, and it still very much continues to this day. And I'll be going into more detail about the consultancy later in this presentation, so I'll skip past it for now. We're a UK company, and I'm actually speaking at the moment from the London office. However, we also have a representative office in Moscow with native Russian staff, and the other 2 boxes here, the red and green, show some of the activities that are mostly that side of CST and the Russian side are involved in. So launch brokerage is something that grew rather organically when we formed the Moscow office in '92. This is something where we as with most of the sort of services of CST, it wasn't something that we intended to initially do when we started, but we saw some customer requirements, and we sort of started pairing people together, and then where we are now is we can negotiate prices for customers, take them through the various contractual stages with the launch provider, and at the final end sort out logistics and help them through the campaign, the launch campaign at the final end. We also have management and trading. So Russia have a lot of interesting and unique aspects to their space industry, some of which is heritage from sort of the Soviet space programs of the past, and some is more shiny and recent. And so we've managed to facilitate some trade between Western and former Soviet and countries in Russia. And one example there is Canopus, and another example which isn't shown is reflectors for Galileo, which we helped bring in from Russia. This is just a brief overview of all of the launches that CST has been involved in. It's 19 so far, the last one being last year. This has totaled 82 satellites. However, my next slide will show that that figure is a little bit misleading. This has included 5 different launch vehicles, and we've had experience from 4 different launch sites. This is a figure from a Euroconsult presentation a few years back. The data in this figure is almost certainly out of date by now. I know that we've launched things since then, and I know others in this pie chart have done the same. What it's really meant to demonstrate is where CST fits in terms of its launch brokerage amongst the other launch brokers. Whilst others like Innovative Solutions in Space, they focus on sort of accommodating several typically CubeSat and NanoSat customers into dispensers and packaging them into larger, sort of more manageable sizes for launch providers. CST, as it started a few years before most of these companies, when CubeSats didn't exist, we focus more on small satellites. That's not to say that CubeSats are completely off topic for us. Where we have supported individual CubeSat launches in the past, and we're in discussions with several people to do the same now. The focus of this presentation, however, won't be on launch, but will be on CST's consultancy side, and that's primarily because at the moment with the COVID virus, we're seeing a lot of uncertainty around launch schedules, and we know that a lot of our friends and colleagues across the world are experiencing challenges in integrating and bringing international teams together to for ICD missions and fit checks and the launch campaign itself. That's something that's quite challenging. So particularly for people who are launching in Russia at the moment, if they need any in-country support because their team is unable to go there physically, then perhaps we should talk, and CST might be able to find some way to support that. Anyway, digging into the consultancy side, this is, as I said, part of CST that has been going from the beginning, and we roughly manage about 20 projects a year. This is turned into quite a considerable volume of work. We have an archive of over 700 projects now, and that number is it's almost closer to 800 now. On this slide, it just gives some examples of the customers and the partners that we've worked with in the past, and some of which I'm pleased to see are actually on this call today. So looking forward to catching up with a lot of them over the course of the next few weeks. This is just a breakdown of some of the subjects that our consultancy covers. It can be roughly broken down into these 5 categories on the left. Some of the subjects are rather are quite hard to fit into one specific genre. So there's a sort of loose strategy category at the bottom there in purple. But starting with launcher technology and in red, and some of the stuff around markets. I mean, these are things that CST need to know for its launch brokerage side to keep us sharp and keep us competitive. So we look into this anyway for our own operations. So it's not too much of an extension to apply this knowledge and expertise to assist other people. So I pulled out a few of the most recent and some of the more interesting examples from our consultancy. The space technology side looks at things wide ranging from power transmission by laser through to radiothermal isotope generators, robotics, nuclear power modules. In terms of some of the applications for these things, we have assisted people on both sides of the investment discussions, both investors looking to understand more about some specific technology they're interested in investing in, whilst people who have that interest in tech who are trying to get sort of impartial reports to support their own pitch have also used some of our reports. Internal planning, a lot of the government customers that we've had have used our reports for various sort of internal strategy discussions, and as well as assessing competition, both commercial and also again within governments, and also assessing risk on the insurance side. This is really how we started, is looking how risks can be mitigated across the space industry, as well as looking at loss adjustment as well. So digging into a few more examples, we have the World Launcher Review, which I've put here because it was a nice collaboration between ourselves and another UK company called Ceradata. They have quite a nice commercially available database. To my knowledge, probably the best database out there for satellites and now launch vehicles. And it was this project was an opportunity for CST to sort of condense a lot of its information from its archives and come out with a pretty concise compendium of all of the launch vehicles that are currently operating. It is a few years since we updated this though, but it's still available if anyone's interested. Importing small Chinese launch vehicles to operate from the UK. I've included this just because it elicited a minor diplomatic incident when we did it. It was under a Innovate UK grant, and it was a feasibility study looking at importing a Chinese vehicle to be operated by an exclusively UK team to get past some of the ITAR restrictions that those Chinese vehicles would experience when they try and cater to international customers domestically. However, we ran into the final conclusions were that because of MTCR, it wasn't feasible, unfortunately. Markets, as I mentioned before, this is something that we've looked at several times now, and the first time was in the mid-2000s for DARPA. This was something that was for DARPA to understand how the Falcon 1 launch vehicle that they had some stakes in was going to perform in the market. Since then, we've been commissioned to do similar studies for launch vehicles in the UK, and the front cover is a little bit sparse, so I've given an extract from somewhere in the middle of this report on the right, which shows the capturable market for forecast for the next 10 years for this specific vehicle that I can't mention, but this we then translate it eventually in this report into the number of attainable launches that this vehicle could achieve in this capturable market. Again, this is one of the more popular ones that we're finding recently. This is just a bit of analysis that we did for
Alan, 1 minute left, please.
Okay, I'll speed up a little bit. So this is just to show that the analysis that we do is quite broad, and this was something that we did with some proprietary modelling. A few people in the UK and in the world that can do this. I know that the good people at Deimos UK and Phil have their own way of methods of assessing trajectories as well. Anyway, just in the final minute, a report that has received a lot of interest is our European Spaceport review. It's a hot topic at the moment. The first was commissioned in 2017 by a UK customer. It's been commissioned several times since then, now by other customers in Europe. The people who are interested in finding out more about the findings of this report, Then there was this year's spring issue of Room. We did an article which covers a lot of the findings. These are some of the nations that this report covers, some of which are still very much advanced in their undertaking to develop a spaceport. Others have unfortunately fallen away for various reasons. And each nation has a chapter dedicated to their spaceport endeavor, and the whole report in total is several hundred pages. So we try and condense all of this, and we look at over 70 variables for each nation. We try and condense all of this information through various sort of open source statistical methods, as well as some proprietary formulas, into a traffic light analysis. And this is just an example of the first page from the 2018 edition. This analysis extends for about 7 pages, and it shows sort of a side-by-side comparison. And we have some controls on the right here from New Zealand and the US, some that are already in operation, to give some context. Anyway, that's everything for now.
Thank you, Alan. Thank you so much. I have received 2 questions for you on the chat line, anonymous, from 2 anonymous people. The first one is, and I think it's for you, how does your shared satellite service compare with Loft Orbital or in-space missions offerings? I think it's for you. If not,
in some ways it's complementary. So as I said, we focus on larger satellites. We know Doug and the team at InSpace very well, for example, and we've been talking to in quite advanced discussions on ways that we can collaborate. CST offers a very bespoke sort of service compared to some of the others that have to sort of standardize their approach to reduce costs. Yeah, I'd say that it's kind of like comparing apples and oranges. We can find larger slots for larger satellites, and we've worked with companies like ACCESS as well to provide to sort of open up larger slots for them to then fill with CubeSats. And we're talking to Doug and others on similar lines. We haven't had any discussions with Loft Orbital, but we're open to it. So if they're listening, then we're all ears.
Next question, anonymous again. What is the current status of Ukrainian launcher market and space technology industrial base?
That is a very good question. We've actually done some reports on this after the situation with Crimea. Diplomatic relations between Russia and Ukraine turned very frosty, and they've been improving very slightly, but they remain very cold because of that. Various programs like the NEPA program, which were commercially very successful, became completely unfeasible. So at the moment, the sad reality from what I can see is that the Ukrainian space industry is fantastic. They inherited a huge amount of heritage from the Soviet days. However, they don't have a launch site. They're not geographically situated in a way, and because they're not on the best of terms with Russia at the moment, they're looking for international partners to accommodate their vehicles, like the Cyclone 4. I know they're looking at Canada at the moment. So and Zenit, another vehicle that was a Russian-Ukraine collaboration, also unfortunately fell at the wayside. So it's not great, but Ukraine, they've got so much experience that they're certainly not out of the equation, and I'm hoping that they'll establish themselves in another country, and we'll hear more from them soon.
One last question for your session, then we're going to go to the general Q&A. When do you expect to see the first UK launch?
Sorry, I probably shouldn't have laughed. The first UK launch, I mean, we want to see it sooner rather than later. I'm sure everyone on the panel and on this webinar would agree. It's dependent on a number of factors. At the moment, from what we can see, the various government departments involved, both sort of locally as well as sort of nationally, they need to coordinate and align their own visions, as well as some of the launch providers and also some of the prospective launch sites to do a bit of crosstalk as well. So we would say that, I would say personally, that I wouldn't expect launch for a couple of years yet, but it's such a volatile part of the industry. We continually have to update the European Spaceport Review because of all of the changes that are happening. So I hope I'll be eating my words and there'll be a launch from the UK even sooner.
All right, great. I think what we should do now is open up the session for a general Q&A. So if everybody can come back to the video, and I'm gonna do the same as myself. So we're gonna have the four of us. If we can, yeah. So we're back. Put on your microphone if you're okay with that. I have already received a couple of questions. Let me start off with a question for all of you, and it's about orbital debris. Since all the three of you are either manufacturing satellites, small, and also launching them, or in the process of helping others to launch them, and also in the monitoring side from Deimos, I suppose. Philip, put your microphone on because it's off. Alan, the same for you. Are you doing anything in particular, either passive or active, to reduce debris in whatever way? And I'm just going to leave it at that, and maybe each one of you can give me some feedback on that. Thank you.
Yeah, I mean, I think in terms of the satellites, we generally meet the requirements of the space licenses of the nations which own the satellites, which is generally in compliance with the IADC deorbit rules, which were fine actually. The 25-year deorbit was fine until the mega constellations came along. People realized with a mega constellation, 25 years is too long when you've got thousands or even tens of thousands of satellites. I mean, we're not in that market, so at the moment we do comply with the 25-year rule. In terms of the space surveillance and tracking, the better you can track everything in space, then the better you can actually do maneuvers to do collision avoidance. The problem with a lot of the data at the moment is that you get the data's not very accurate, and you get a lot of warnings, and it's difficult to know whether you should do anything about them or not. If you had better space surveillance and tracking data, which was more accurate, you could actually know which ones of the current ones you could ignore and which ones you really ought to do something about when you have the ability to do a collision avoidance maneuver. So we and lots of other systems around the world are improving the tracking of space. In particular, the low Earth orbit where we operate, one of our telescopes in Spain actually tracks things flying in the low Earth orbit. We get very, very good data, which complements the radar data that comes from systems like the US and so on. So I think there is a general improvement in the tracking going on, which helps, but it doesn't it mitigates, but it doesn't remove the problem. The problem really is a serious one, and we do have to look at making the debris mitigation rules much stronger in the future than they have been in the past.
All right, so more authority, more sort of guidelines coming up. Alan or Giuseppe, anything to say on this point?
Okay, from an Endurosat point of view, as per Deimos, I mean, we are compliant with the 25 years rule. And I fully agree with Philip that this rule actually is obsolete now because of the mega constellation. Regarding Endurosat, we have launched always satellites which are actually below the ISS so far. So they re-enter in less than 2 years or 1 year and a half. So we haven't faced this problem. And I'm going to reply also one question that I found in the chat about the propulsion system. we do everything but propulsion. So when a satellite will require propulsion, for example, for re-entering and disposing the satellites, in this case, we will integrate a third-party propulsion system. So we partner with some of them. We have already exchanged ICD and part of the integration. So we can easily integrate also propulsion systems in order also to be compliant with the 25 years rule if we go higher than 400 kilometers. And we do not have any plan to launch any mega constellation. So we don't want to throw garbage too much in space. And with the shared satellite service, actually, probably we plan to reduce it a bit because a customer, instead of flying another satellite, will share a satellite with us, and it's a one satellite less.
If I may disagree with you, Giuseppe, I don't think mega constellation are throwing garbage. They should be made responsible for their satellites, and they should be sort of deorbited back to Earth. And I think the mega constellations are doing that. At least OneWeb. I know OneWeb is doing it. Maybe SpaceX is more passive. That's why they went down to the lower height, so that they can be deorbited naturally. But the biggest issue is CubeSats, those satellites that don't have a propulsion system. And that's why I asked the question in this respect, more for the 1 kilogram, 10 kilogram, whatever they are, that may not have any active propulsion. The question is more, are there any technology you are adopting on the passive side, maybe, or even active, that might help deorbit those satellites? I suppose that you're going below the ISS because naturally they would take a few months to maybe a year or two to deorbit naturally, in effect. And the 25-year rule was adopted in a time when there were no, or very little, let's say, small satellites that we're talking about, and it was more for the larger, bigger satellites, and it was space agencies who actually came up with it. IADC came up with the rule itself. Okay, maybe I would move on to, sorry to have asked and provided a feedback, but Alan, on your side, for the launcher side, because debris can also be caused by launchers here, not necessarily only satellites. A lot of the debris that we have today still it lingers around because of the earlier launch missions, in effect. What do you have to say about that?
Well, that's very true. Some of the models of the vehicles behind me are responsible for that, and there's still, yeah, some of the upper stages are still floating around. Well, I know that launchers now, especially the new ones that are being developed, they're looking at ways of separating stages so that it doesn't produce any sort of small fragments of debris. So they use sort of spring mechanisms rather than pyrotechnics. CST, we're not directly involved in the discussions around space debris. That we leave that to our customers. But we have been involved on the consultancy side in looking at how the licensing requirements around space debris would impact on some of our customers. When asked, we actually completed a study this year, and it's interesting to note that in the UK, just as it is with most of the other countries in the world now, the requirements are tightening. And from what we found for this particular customer, if they're launching from the ISS or lower, the conversation with the regulator is fairly straightforward. Anything above the ISS, and they need active collision avoidance, as well as a means to deorbit after end of mission. And that actually would change the design of the satellite above ISS. So that is something to factor for people who are looking to launch or license in the UK.
Thanks, Alan. I'm not going to ask any more questions about Star Trek behind you, Philip, if they cause any debris, but let's move on with additional questions which I have received for you guys. Philip, on your side, I have a question here. What are the key what does Deimos consider as key growth areas for its business in the coming years?
Yeah, that's a good question. I mean, the one we've just been talking about is a key area, space surveillance and tracking. It's one of the reasons that we invested in our own observatory. We see that as a growing need. The capability is needed more widely, and the world needs more sensors. So we sell data from that system commercially, mainly to institutional customers. So that's certainly a growth area. For us in Deimos as well, things like the EO applications area is always growing. More and more uses can be made of the data, and as I say in the presentation, using machine learning makes it easier to do new applications of data. On top of that, I mean, for Deimos UK, the launch thing's been a real big growth area in the last few years. We're now heavily integrated into a lot of the UK activities around Orbex and around the spaceports, particularly Sutherland. But we've also been involved in some of the work on the horizontal spaceport. We recently participated in a study looking at the Llanbedr Snowdonia spaceport, looking at quite different activities to the activities we're looking at from Sutherland.
Thanks, Philip. Question for Mark Paulsen here for Endurosat, but it may be applicable also to others. Your shared satellite concept is very interesting. You have multiple payloads hosted on the platform, basically. But however, Mark, being a spectrum engineer like I am, and taking care of frequencies and regulatory issues, how do you manage the international and domestic spectrum regulatory and licensing aspect of such mission, since it carries multiple payloads of different entities?
Yeah, this I might not be the right person to reply these questions because I'm not a regulatory guy. I can say that the satellite that we launched with the shared satellite service is owned and is operated by Endurosat. So each payload will be integrated in the Endurosat platform, and we will operate it. So the full regulatory compliance will be on us, not on the owner of each payload. And everything will go through our ground station as well. So everything, what the client receives is only the final data.
So basically you have a time share, I suppose, of the resource, the frequency
time
resource.
and resources share. So someone can ask more power or more time or more data rates.
Okay, it makes more sense to have a time share of the same resource. That way, they don't have to coordinate spectrum between themselves, basically. At the end of the day, a frequency is just a medium over which you carry data, and the data is being time shared between different payloads. In regards to Alan, let me find. I have a question for you, Alan. Actually, I don't have a question for you, Alan. So let me find on. I thought I had a question from anonymous one. I thought I've seen it, but let me just see on the screen, the Q&A screen.
There's all these anonymous questions for me.
How useful? Here it is. How useful would it be a high thrust nanosat propulsion system for the satellite operability and the revenues? I think that most likely is for Endurosat, but if you have an answer to that, I can repeat it.
Oh, just as the final point when I was answering the last question about the findings that we had for this particular customer just at the beginning of this year, that they would have to look at a propulsion system, or well, they wouldn't have to, but it would seriously help their discussions with the regulators in getting a launch license if they had a propulsion system so that they could go into a higher orbit above the ISS, which offers some benefits to their mission. So I would say that a small propulsion system that can fit in a CubeSat would be useful.
The other more pertinent question for you, actually, it's do you have any experience in manned missions or related services?
No, we have had some discussions with people who were interested in getting in opening up discussions with people in Russia to try and get some collaboration going, and maybe a share of some of the assets and the capabilities that they have in Russia. But those discussions are just sort of fairly provisional, early stage stuff. So other than that, no. But it's interesting, and it's certainly going to be something that will become more relevant as space tourism and things progress.
Robin Tucker has a question actually for you, Alan. Robin, can you speak and provide your question directly?
Yes, sure.
Can you introduce yourself, where you're from, and what you do, and then ask the question, please?
Yes, so I run a management consultancy firm called Red Kite Management Consulting, which is a general business strategy firm. So we work with all different companies, more at the applications end of things. So I'm interested in whether the Chinese are emerging to take the position that the Russians once had as providing the budget end of the launch market, or whether Elon Musk and SpaceX have really now got that end of the market firmly cornered. And of course, any comments on how the British developments are going to play into that will be interesting as well.
It's a good question. It's a sort of multi-layered question. The Chinese have had a great potential, and they've had hit some very major milestones recently with their launches. Also had a few unfortunate failures because they really are pushing the boundaries, but they are ultimately restricted by ITAR and some other internationally sort of focused regulations. So that does limit their abilities to capture a truly sort of international, especially Western market. Whereas Russia, despite some political issues in recent years, they're still more open, and Western companies can still use their launch vehicles a lot easier than you could with the Chinese. Regarding SpaceX, they have positioned themselves. I would say that they position themselves now as probably the top competitor in terms of price, and that's not a bad thing. I think it's good to place a flag in the sand and make everyone else try and reach the same sort of competitive level. In Russia, they're certainly achieving that by finding ways to simplify the Soyuz, because parts of it are, like the frigate upper stage, are incredible bits of kit but a bit over engineered for the job. So by simplifying bits, they can reduce the price and remain competitive. But I mean, ultimately, the volume of launches that SpaceX are doing at the moment for Starlink means that they really can reduce costs and prices.
Thanks. 2 more minutes, and then we finish. Thank you for bearing with us. I have 2 more questions here, which I would like to ask irrespectively. And if people have to leave, please do leave. The last 2 questions I have on the Q&A are: is there any use cases that integrate nanosat and some IoT devices? And what are the frequency bands for this kind of nanosat? Who can answer that? Giuseppe, maybe?
Yeah, I'm not sure if I got the questions. The question, definitely there are nanosatellites which are now used for IoT services. We have several companies, and some of them actually Endurosat is even providing them systems. You can name them Kepler Communication from Canada, Astrocast Switzerland or Fleet in Australia. So they provide IoT services through space, through their constellations. Frequencies used Ka band for Kepler communication, and I'm not sure for the other companies. So I don't know if anyone else on the panel can reply to this question.
Yeah, and no, thank you for that. I have Robin Tucker saying that there is a service called Lacuna. I think it's Lacuna Space, which was started by someone he knows that is providing that kind of activities and integration. Basically, it's an integration between CubeSats and most likely or small sats and IoT devices at the moment. We also know there are some constellations in Europe and Australia that are trying to deploy constellations like Mariota or even another one from Kinéis from France. There are others like even Iber and so on and so on. One more questions as I asked the last question to Philip. Just be aware there's a poll. There's a poll here. Yes, Robin, Lacuna Space is actually a member of ACCESS.SPACE. Thank you for that. The poll is running. Anybody still needs to answer the poll, please do that the last 1 minute. And in the meantime, I'll ask a question to Philip, maybe because he's most likely well aware and maybe he can provide his knowledge on mega constellations. I wouldn't call them mega because they don't have 1 million satellites. So I would call them large constellations because they have less than 1,000 at the moment. That's my view. Anyway, how realistic are autonomous mega constellations? And when will they get there? I never heard about this.
No, I think if I understand the question correctly, constellations where there's a lot of onboard autonomy, I'd say any mega constellation requires that, because you can't have a team of people on the ground babysitting those satellites. If you've got hundreds or thousands of them, you need the system to be autonomous. The interface between the humans and the system needs to be at the level of the planning of the mission and responding to anomalies that the onboard system can't handle itself. But everything else that's routine needs to be autonomous.
So you are saying that we need some artificial intelligence that would help?
Well, it's not necessarily artificial intelligence. You know, you can have planned autonomy. You can have mission timelines where the system knows what it's got to be doing at each minute of the day. It doesn't necessarily need artificial intelligence. The tricky part is when you get to the FDIR, the failure detection, the isolation and recovery, when you get anomalies. That's perhaps an area where there is an application for AI, because it's quite complex what you do when things start to fail. Learning from a human being about what all the responses to the different things. It's quite useful. People have been looking at that for quite a long time. But in the end, if the onboard system knows that it's had a failure and it's not sure what to do about it, you need to have built in a safe mode into the system anyway, where it goes into a safe attitude, that there's power being generated and the satellite can basically travel along in safe mode until a human being analyzes it and works out what it needs to do.
All right, thank you so much. For the attendees, we have finished our webinar this week. We hope you can actually attend next week again. If you have any questions to the panelists, you have their emails, or if you have any specific questions also on ACCESS.SPACE, please do send me an email and I will get your questions answered as soon as possible. Please do stay in touch, and hope you join us also next week and the following weeks. Thank you so much. Stay safe and all the best. Bye-bye.
Yeah, thanks.
To the panelists as well.
Thank you. Bye.
Yeah, thank you, Tony.
You're welcome. Take care. Bye-bye.
Bye then.